Welcome to Chem We Talk, a channel where we're not afraid to talk about any chemistry topic. In today's video, we'll start our discussion about nomenclature of simple inorganic compounds by going over the naming of cations and hydroxides. Please make sure you subscribe to the channel so that you get the notifications of the new videos that will be released very soon. Okay, so those are our learning objectives in today's video. We're going to start by reviewing the chart of most common cations, followed by the nomenclature of those cations. Then we're going to move on to discuss how to use the suffix "ic" and OUS, which are going to be very relevant for naming salts and acids, which is going to be the topic of the next video. And finally, we're going to wrap up with naming hydroxides. All right, so cations. So you should know from previous videos that cations are positively charged ions, and they're usually derived from metals, such as in my example here, lithium plus and aluminum 3+, but there are a few exceptions that are going to be relevant in general chemistry, which are the ammonium ion, which is derived from ammonia. That's going to be an H4+, the ion, and also the H+, which is going to be your hydrogen ion. Okay, out of the metal cations, we're going to divide those into two main groups. The first one, the groups of the metals that can only adopt one charge. And secondly, we're going to have the metals that can adopt different charges. Let's start with the first group. Okay, so we have a periodic table right here. And we're going to start with group 1A. Just looking at the metals, remember hydrogen is in group 1 or group 1A, but it's not a metal. Okay, so metals from group 1 always going to be +1. So lithium, sodium, potassium, rubidium, cesium, francium, always going to be +1. Same rule applies for group 2, but instead of being +1, they're going to be +2. So all the metals from group 2 are going to be +2. And there are also a few exceptions that are good to be memorized. You should memorize them for your exams. We're going to have cadmium, zinc, and aluminum. So cadmium and zinc are going to be 2+ always, and aluminum is always going to be 3+. Okay, so and for naming those metal ions that only have one single oxidation state, we're just going to use the element name plus the word ion at the end. So for example, we have zinc. Zinc only has one charge, so we can just simply call it zinc ion, and that's it. Okay, now we move to a little bit more complicated group, which is a group of metals that can adopt more than one oxidation state. And we're going to start with the group of +1, +2, which has copper and also has mercury. So they can be +1 or +2, and mercury can be +1, +2. You might be confused, okay, why there's like a 2+ here, not a +1, but you can see that you have two mercury ions. So if you take the average, you're going to be +1. So this here would be +1, this here would be +2. We also have the group of metals that can be +2, +3, which are going to be the iron, cobalt, nickel. So iron 2, iron 3, cobalt 2, cobalt 3, nickel 2, nickel 3. And lastly, we have our group of 2+ and 4+. So we have lead that can be +2, +4, platinum, and tin. Okay. So for naming, it's going to be a little different because we cannot simply use the element name, but we need to now use a charge in parentheses plus the word ion. That's the most common used nomenclature right now. Or there's another nomenclature that uses the suffixes OUS and ic as well, plus the word ion at the end. And the OUS suffix would be for the lowest charge in a group, while the ic suffix would be used for the highest charge in a group. So let's look, for example, here in the group 1, 2. If I have a charge of 2+, that is the highest charge, so the suffix would be ic. If I still have a 2+ charge, but now I'm a metal that has, let's say, iron, that could be +2 or +3. Now the 2+ is the lowest charge, so the suffix would be OUS. So be careful, the OUS and ic are always related to the charge within a group. Okay, let's look at some examples. Let's look at iron 2+. So iron 2+, it is in the 2+, 3+ group. So the first nomenclature is just using the name of the element, which is iron, the charge with Roman numerals in parentheses to ion, or we can use the suffix, which is the older nomenclature, ferrous ion. And then remember, the OUS is the lowest charge of a group, so we know iron is in group 2 and 3, and 2 is the lowest charge, so that's why we use OUS. If we had the 3+ charge for iron, it would be iron 3 ion or ferric ion, okay? Because now the 3+ is the highest charge. Okay, let's look at a few problems here. Start with magnesium 2+. So we know that it is a cation from a metal from group 2 in the periodic table, and we know that cations from metals from the group 2 are always going to be 2+, which means we're just going to simply call it magnesium ion and call it a day. So just be careful. It would definitely be redundant to say magnesium 2 ion because magnesium is always 2, so there's no need for it, and it's actually incorrect, so we don't use it. Okay. Moving on to the next one, so copper plus. First thing we notice is that the copper plus is not part of group 1 or 2, and it's not one of the exceptions you should memorize. So we need to remember our table, and we can see that copper is in the group of +1, +2, and because it is +1, we can just say it copper 1 ion to distinguish between the possibility of copper 2. And if you use the older nomenclature, the 1 plus is the lowest charge, so it would be cuprous ion. Okay. All right. So moving on to the next one. So we have zinc 2 plus. We know that it's not a metal from group 1 and 2, but it is one of the exceptions that you should memorize. So zinc 2 plus, so it can only be 2 plus. So simply the answer would be zinc ion. Then let's go to tin 4 plus. We know that's not part of group 1 or 2, and it's also not part of the exception, so we can adopt two different oxidation states. Okay, so it can be either 2 plus or 4 plus. It is in that group, and 4 plus is the largest number, right? So we can say tin 4 ion, or we can use stenic. Remember, the 4 plus is the highest, so we need to use the suffix ic, and stenic just means it is, this word comes from Latin. That's why it's the compound, the element's also SN, not Ti, for example. And just want to point out this here that if you say stenic 4 ion would also be redundant because the ic here already tells you that the charge should be 4 plus, so you should not use stenic 4 ion. Okay. All right, so that's the answer for those problems. Now let's go over an opposite problem where you're given the name of the ion. Now you need to write down the ion. So first thing is identify the element. So for the first one, you have plumbous ion, so Pb. The fact that you have this OUS terminations already give you a hint that you might have more than one oxidation state possible for the metal. And we know the lead is in the group of 2 plus 4 plus, so the OUS is the lowest value, so it should be Pb2 plus. Lithium ion doesn't have any Roman numerals, there's no OUS or ic. Lithium is also in group 1, so it's always going to be lithium plus 1. So there's nothing to do, it's always going to be plus 1 because it's in group 1. Now this one's a little easier just because you already have the charge written there. So nickel, we know it's Ni, and the charge is 2 plus, and we call it a day. And then cadmium ion, it's not from group 1 and group 2, but it is one of your exceptions that you should memorize, that it is always 2 plus, so it should be cadmium 2 plus. All right, so let's shift the gears a little bit, and I'll start talking about hydroxides, which are going to have the similar nomenclature rules. Okay, so let's just define hydroxides first. They are ionic compounds made up of cations. Usually they're going to be from metals. There might be a few exceptions. And the OH anion, and the OH anion is also called the hydroxide anion. Okay, this family of compounds is very important, and they usually dissolve in water and will behave as bases. And that's going to be important for our discussions later on about pH calculations. Okay. One thing I want to point out is the hydroxides are neutral compounds, which means that the total negative charge should be equal to the total positive charge. Okay, so let's just look at this example here. We have LiOH and copper OH2. We know that OH is always -1, and we know that lithium is always +1. So by having one single lithium and one single OH minus, we get this the charge neutrality. Here we have copper 2 plus, but every OH is only -1. Therefore, we need an extra OH. That's why I have a copper OH2 instead. Okay. For naming is going to be relatively simple now that we already discussed the nomenclature of cations. So simply, we're going to have the cation name plus the word hydroxide at the end. Let's practice on those two here. So we know that lithium can only have one single charge. So the name of the cation is just lithium ion. So it's just going to be lithium hydroxide. In the case of copper, we know that copper is not group 1 or 2, and it's not among the exceptions, and it is in fact in the group of elements that can have charge +1, +2. And in this case, because it is +2, we're going to have the highest charge possible in the group. So we can have copper 2 hydroxide, or we can have a cupric hydroxide. Both of those should work. All right, so let's go here to another practice problem. So we start with NaOH. So first thing we notice is that it is a hydroxide that contains a cation from a metal from group 1 in the periodic table. Therefore, the metal can only adopt the charge of 1, and we're going to have the name just being sodium hydroxide. So there's no suffix, there's no charge in parentheses, just literally the name of the element plus the word hydroxide. This one's a little different. We know that iron, it's not a metal from groups 1 or 2, and it's also not one of the exceptions. And if we look at the number of hydroxides, we see that we have 2 hydroxides, right? So the total negative charge is -2, which makes iron, in our case, being 2+. And if you remember correctly, the iron is in the group of 2+, 3+. So if you want to use the OUS nomenclature, you need to go to the lowest one, which is OUS. So we can simply call it iron 2 hydroxide if you use the Roman numerals notation, or we would use ferrous hydroxide. Both are correct. Now let's go to next one, aluminum OH3. In this case, the cation present in the hydroxide is not from group 1 or 2, but it is one of the exceptions, so it only has a single oxidation state, so simply just read the name of the metal plus hydroxide, and that's it. Now lastly, we have copper OH2. Now the cation is not a metal from groups 1 or 2, and it's also not one of the exceptions. And if we look at the charge here, we have 2 OH-, so we have a total charge of -2, which makes copper 2+ cation. And copper, it is in the group of +1, +2, right? So if it is +2, we're going to have copper 2 hydroxide or cupric, because now the 2+ is the highest value of that group. All right. Cool. Now let's do the opposite problem. We're just going to be given the formula, and now we need to come up with the equation. So ammonium hydroxide, so we know that has OH-, and ammonium, if you remember, that's one of the exceptions of the cations that are not fully inorganic, it's not only metals. So we know there's NH4 plus and OH-. Plus and minus already would cancel each other out. There's no need to balance anything inside the compound, so we just get NH4OH. Now you have ferric hydroxide. That means you have iron and OH-, and remember, this ic termination means that you have a variable oxidation state metal, and iron is in the group of 2+, 3+, right? So the ic means that you have the highest oxidation state possible, which would be the 3+. So if I would combine Fe and OH-, it would not be neutrally charge neutral, right? Because you have 3+ and OH-, you would get a net of +2 still. So we would need to have 3 OH- to compensate for the charge of the iron. So we're going to get ferric hydroxide being FeOH3. Now we have lead 4 hydroxide, sorry. So we're going to have OH- and lead 4+. And for the same argument we use here, if we would just combine those two, we're going to get not a charge neutral compound. So we need 4 OH- to compensate for the +4 charge there. And lastly, we have zinc hydroxide. So we're going to have OH-, and we know that zinc, it's not in group 1 or 2, but it is one of the exceptions which has a fixed oxidation state, which is 2+. So if we combine those two, you're also not going to get a neutral compound. So you need to have 2 OH- to compensate for the 2+, and you get zinc OH2. All right, so just in summary, we know that cations are positively charged species, usually derived from metals, but there are a few exceptions like the NH4+ and H+. Some metals can only form cations with the same charge, like lithium, sodium, like those metals from groups 1 and 2, while others can form cations with different charges, like, for example, iron that can be 2+ and 3+. Okay, so for those that only have a single oxidation state, the naming is very simple. Just read the element name plus the word ion. So in this case would be lithium ion. For the cations that have different oxidation states, there are 2 options. One is just read the element name with the charge in parentheses plus ion. So for example, here would be iron 2 ion, or here would be iron 3 ion. Or we could use the older nomenclature that uses OUS and IC. Those suffixes would indicate the lowest charge in a group and the highest charge in a group. So for the iron case, this here would be the ferrous ion, this here would be the ferric ion. Okay. Lastly, we discussed about hydroxides, which are ionic compounds made of cations, usually from metals, and the OH anion. Those are neutral compounds, so when writing down your hydroxides, you might be careful because you need to make sure the chart is balanced. So you might need to add some extra OH, like in parentheses, to compensate for the charge of the metal. The naming is very straightforward if you understand the naming of the cations. So it's just going to be simply the name of the cation plus the word hydroxide at the end. And although those OUS ink notations are not very often used anymore, understanding these naming rules will be critical for naming acids and salts, which is going to be the topic for the next video. Okay. All right. Thank you again for watching. Please follow us on social media and please share with your colleagues, friends, and lab mates. All right. See you next time. Bye-bye.